We are the Gujarat Technological University. Since its inception over a decade ago, GTU has been empowering young and curating minds to realize their true potential. Over 4 lakh inspired students are enrolled with one of the premier academic universities in India. With more than 450 affiliated colleges in its fold operating across 5 zones of the state, GTU, the International Innovative University, your place to move forward.
Hello everyone, today we will talk about weak slot and filler structures, Unit 8, Artificial Intelligence. Now, before going to weak slot and filler structures, we will see what is this unit is about. Weak slot and filler structure is a kind of a slot and filler structure. It is a knowledge representation technique. Okay, there are actually 2 kinds of slot and filler structures, weak and strong. Now, what is exactly slot and filler structures? It is, we can say, attribute value pair, slot and filler. We will see it in detail. Let's see. Why weak slot and filler structures we are going to study and use. It enables attribute values to be retrieved very quickly. Properties of relations are easy to describe. It allows ease of consideration as it embraces the aspects of object-oriented programming. Now, this is the knowledge representation technique that we are using for storing certain type of knowledge using attribute value pair. And one of the technique is weak slot and filler structures. Among this weak slot and filler structures, there are various types that we will see. One is the semantic net and another is the frame. What is slot and filler? A slot is an attribute value pair in its simplest form, we can say. Filler is a value that a slot can take. Okay, means that there is empty space that we have to fill. The particular thing using which we have to fill is the value, is a filler. And the empty place means that is the slot. Okay, filler can be any numeric, string, or any kind of value or point to that particular slot. Weak slot and filler structure does not consider the content of representation. The example is semantic nets and frames. Next, let's see semantic net. What is the major idea behind the semantic net? The simple way of representing the relationship between entity and concept. Means we just wanted a simplest way of representation between concepts and entity. So we just move on to the concept semantic nets. The meaning of concept comes from its relationship to the other concepts, and that semantic nets are graphical networks. So the information is stored by interconnecting nodes. Means there are 2 nodes that are connected with labeled arcs. Means that particular arrows between 2 concepts have certain labels. That label shows the relationship between that 2 nodes or concepts. Okay, semantic net initially we used to represent labeled connections between nodes. Means node represent connections, node represent concepts, and arc or arrows represent relationship between concepts. Let's see the example. My call is an instance of a person. Person is a mammal. Person has part, head. My call belongs to the team Cardiff. My call team colors is black or blue. Okay, so over here we can see these are the relationships between these 2 concepts like person and my call. How they are related, then we can say my call is an instance of a person. Means my call is a person. Person and mammal, how they are related? Person is a mammal. Person has part, head. Means any mammal has part, head. Person has part, head. Unary relations and predicate logic can also be represented as binary in this semantic net using ISA and instance relationship. Okay, means using turning that relations into object, we can represent that unary relations in a predicate logic, like person is a mammal. Okay, my call is a person. One shows the instance relationship, another shows the is a relationship between these two concepts, mammal and person, person and my call, in a predicate logic. So it is also one kind of advantage of semantic net. Like this, we can represent is a person mammal, means is a relationship between person and mammal. My call person, so it is related with instance relationship. My call is a team Cardiff, means my call belongs to team Cardiff, so they are related with team. This is how we can represent this concept in a semantic net. Another sentence we will see, John gave the Mary book. This is a one kind of a complex sentence. We have several aspects of event, which are the event in this sentence. We can see John gave the Mary book. That is a whole event. We can see one event is there. Gave means giving is one kind of instance of that event. Mary is receiving something, that is also one kind of event. Means this event is related with Mary by receiver relation. John is related with this event, means he is the doer of this event. So it is related with agent relation. Which object is used in this event? That is book. So book and event are related with object relationship. Book can be, this can be any instance of books. Give. Okay, this is how any semantic net can be represented for complex sentence. But we can see it is quite complex to represent this kind of sentence. John gave the Mary book. So this is one, we can say, disadvantage of semantic net. We will see that in at the last. Semantic net for this kind of sentences. Let's see. Tom is a cat. We can see clearly over here, cat and Tom is related with is a relationship, binary relationship, is a. We can represent it easily, Tom and cat with relation, is a on this arrow. Tom caught fish. Tom and fish is related with caught a relationship. Okay, so this two concepts are connected with this arrow using caught label. Tom is gray in color, means Tom and gray, these two entities are connected with relationship color, means Tom and gray. How they are related? Then Tom's color is gray. Tom is owned by Sam. How Tom and Sam is related? Then Tom is owned by Sam. Tom is a mammal. So Tom is a mammal, but first of all, Tom is a cat. So any cat is a mammal. So we can represent it like this. Tom is a cat and cat is a mammal. Fish is an animal. So we will represent this concept fish with is a relationship with animal. Cats love milk. Cat loves milk. Cat and milk are related with loves relationship. Okay, all mammals are animals. Mammals, animals. Any mammal is a animal. This is how we can represent the semantic net for all these sentences. Means all the sentences are stored in the form of this graphical representation. Now, how we can use it, we will see it now. This is the example from our textbook only. Let's see how it can be used, this semantic net. Semantic net can be used for intersection search, means asking certain questions between particular nodes and relationships. We can find out the answers. Okay, we will see it at the last how we can do that, as if we are doing in a prologue. Like over here, Tom is a mammal. Who is a mammal? Tom is a mammal. Then over here we can see mammal, cat and Tom. So this is how we got the answer. Tom is a mammal. Okay, who loves milk? Cat loves milk. Okay, loves relationship with milk is with cat. So this is how we can find out the answer. This is nothing but a simply intersection search. Inheritance. The ISA and instance representation provide a mechanism to implement the inheritance. We already know the advantage of inheritance in a knowledge representations in a, I think we have seen in a unit 3. Inheritance provide the means of dealing with default reasoning. Okay, for example, over here we have shown this sentences. Emus are birds. Typically birds fly and have wings, and emus runs. So there are entities like emu, bird, fly, wings, run. Okay, now let's connect it with relationship. Like bird and emu. We can say that emu is an instance of a bird. Okay, the emu is an instance of it's a kind of a bird, so we can say emu is an instance of bird. Bird, generally what action it does? Fly. Bird action, bird flies. So we can show bird action, fly. Bird have wings. Okay, typically bird flies and have wings. Bird have wings. Any bird has part wings. Okay, emu can run. Emu can does action run. This is how we can show the particular knowledge. Over here, what we can deduce, emu is a kind of a bird. Okay, typically birds can fly and have wings, but even though emu is a bird, it have the properties of bird inherited from this object bird, but it can run also. This is the knowledge that we can deduce from this semantic net using inheritance property. Okay, now let's see the next advantage, or we can say use of semantic net. That is, we can make inference by converting a particular thing to the semantic net. Like over here, the example is given like compare the height of two persons. For example, Bill is taller than John. I want to infer that particular the sentence is true or not. Then what we have to do? First of all, we have to how I can show this concept. Bill and John. How they are related? Taller than means Bill is taller than John. How I can find it or infer it? Then I have to first find out the height of a Bill, that is h1. Then I have to find out the height of John, that is h2. If h1 is greater than h2, means I have certain value. Okay, if h1 is greater than h2, then I can say that Bill is taller than John. This is how we can use semantic net for making inference by converting the particular fact into the semantic nets. Now let's see the advantages, list of advantages of semantic net. It is easy to visualize and understand because we can say it is a natural way of organizing information and the way human think. Generally, we all know how to represent particular things using this concepts, means nodes and arcs, even before knowing this semantic net. So it is, we can say it is a general way of organizing information the way human think. So it is easier to visualize and understand. Related knowledge is easily categorized, means as we know it is a natural way of organizing information. So related knowledge, we just categorize it very easily with using our natural instincts. Efficient in space requirements, we just need to have need to store only attribute value pair only, means relationship, and that relationship is between which two concepts, that order pair that we have to store. Translated to Prolog without difficulty, which is, we have already seen that the statements are very much similar over here, very much similar to the this one, very much similar to the particular Prolog statements. So it is easier to convert into Prolog statements without difficulty. Node object represented only once, that is, it has the property of inheritance. Default reasoning, that is also due to inheritance property of semantic net. Easy to find answers to any query, like just now we have seen how it can be done using intersection search. Okay, so that are the advantages of semantic net. But what is the disadvantage? There are certain disadvantage of semantic net. There is no standard definition of linked names, means how I can label that particular R. There is no particular definition. I can define it as per my intelligence. Semantic nets are not intelligent, dependent on creator. Undistinguished nodes that represent classes and that represent individual objects. Negation, disjunction, general non-taxonomic knowledge are not easily expressed. This just can express simple binary relationships very easily. We have seen the example in that we can see simple relationship we can easily express using semantic net, but certain complex statements it's quite difficult to make. Links on object represent only binary relations. Binary relations are easy to represent but sometimes difficult in complex sentences. Like see this sentence, John caused trouble to the party. John caused trouble to the party. Means John and party, these two entities are related with caused trouble, means trouble. But who caused trouble? John. To whom? Party. So we can see that though it is a binary relationship, trouble between John and party, that is quite difficult to express. Let's see. Cause. Who caused? John. Where? Party. What it caused? Trouble. So we can see how John and party are related with trouble. But the representation is quite difficult. One more disadvantage is that we cannot express quantified statements using simple semantic nets. Let's try to represent every dog has bitten postman. We can represent dog bitten postman, but we cannot say every dog bitten every postman or every dog bitten a postman. Okay, there is no any kind of mechanism to show this quantification. So as a solution, we are having partitioned semantic nets. It can represent quantified statements. Let's see. Semantic nets are divided into one or more network for the description of individual events. That is nothing but a partitioned semantic net. Partitioning allows group, nodes and arc to be bundled together into units called spaces. Same labeled nodes and arcs. Every nodes and arcs of network belong to one or more spaces. Over here it is S1 space. Specific sentence about specific dog can be represented using simple semantic net. Over here like this. Danny the dog beat the Peter the postman. Danny is a dog. What it is doing? Biting. B means agent of this event. B. B is biting. Who is the patient of this event? Peter is a postman. That is we will call semantic space S1. Now to represent, this is we can represent using semantic net because it don't contain any kind of quantified statement. Now let's see this sentence. Every dog has bitten every postman. Now every dog, not Danny the dog, every dog has bitten every postman. How we can represent it? There are two semantic spaces, partitions, SA and S1. This is SA and this is S1. S1 is quite similar to the previous one we have seen. D is a dog, B is a bite, P is a postman. Okay. D is the agent of V and P is the patient of particular event V. Okay, G represents generalized statements form and one universal quantifier. Okay, this is how particular semantic net works. What are the application in the current time we can see? To merge the data from several databases to one platform, to maintain translation of names and documents, to index and classify relevant documents, to maintain data by non-IT people because it is natural way of formal representation. Now just concentrate on this first three applications, like to merge data from several databases. Databases contains some attribute value pair. Okay, so semantic net also have attribute value pair as it is a kind of a weak slot and filler structure. Okay, so, in another example, translation of name and documents, it is again attribute value pair. Okay, index and classify relevant documents means index and document are related, means again it is attribute value pair. So over here we can use semantic net to easily visualize it and to merge it, as it is a natural way of understanding and visualizing concepts, semantic net. So it is easier way to merge it. These first three applications are very easier to perform using semantic nets. Frames. It is an extension of semantic net. Frame is a collection of attributes or slot associated value that describe some real world entity. Frame on their own are not particularly helpful, but frame systems are powerful way of encoding information to support the reasoning. Set theory provides good basis for understanding of the frame system. Means it is same like class and its instance. Means we are having a set and elements of that particular sets. Okay, let's see, understand it by example. Frame is a collection of attributes or slots and associated values. Just understand one thing, wherever slots are there, that slot have values, associated values from the real world entities. Now, let's see, slot can be of any size and type. Okay, slot can have names and values of different faces. Let's see the example. First, RAM. Now, RAM is associated with the profession. The value is professor. Okay. Now, age of RAM. Then value is 50 over here. Okay. Now, wife. RAM and wife. What is the value of wife of RAM? That is Sita. Okay. Children. The value is Love and Kush. Address. Then in address again we are specifying the another thing, that is street. Then we can say it is value is 4C Road. Okay, city. Then we can show the value Banaras. This is how we can represent any knowledge using frames. Okay. These are some of the GTU questions that we have extracted from the previous GTU papers. There are many others that you can also refer. All the best. Thank you.